So let's talk about PowerShell. First, let's be nice to each other. You've seen these repeatedly throughout the week. Let's make sure that we look out for our friends amongst us and keep our phones on silent. And of course, if we need to go take a phone call, then that's cool. Don't forget, if you are not a member of your local user group already, hello. Yeah, I'm not Pinar Davi. I'm Rob. We're talking PowerShell. Knew this was going to happen. We'll do that a few times, I expect. It's cool. If you're not a member of your local user group, then please do find out, reach out for your user group. Go down to the community zone, have a chat with the people there, and find out where your local user group is, because it's another year until we have another PASS Summit. And it won't be here, it'll be in Houston. So between now and then, there's a whole bundle of things that you can do to carry on your learning. Your user group is a great place to go and find out your network, to meet with people in your local area and share knowledge. And also, you've got your virtual groups, so you can access those through a browser anytime throughout the year. There'll be 24 hours PASS marathons. Myself and Hamish run the DevOps virtual group, so we get people in doing some DevOps, but there's virtual user groups for all of the things that you could possibly want to learn. So who am I? My name's Rob. Most important thing to know about me is you are welcome to get in touch with me anytime you like. And thank you. Let's try that again. My website is SQLDBAwithabeard.com. That's where I do my blogging. You're welcome to connect with me on LinkedIn. You will find that I'm quite active on Twitter. But to find me on Twitter, you have to make sure that you look for SQLDBA with beard. Because when I first changed my handle, I didn't realize that Twitter had a 15-character limit. So I became SQLDBA with a bear, which is cool. So I kept it, because it's kind of fun. Let's go back to there. I'm a consultant. I go in and help people with automation, delivery of DevOps, database changes. And I love to automate things. I've been doing PowerShell for many, many years, and all I love to do is to take those manual, boring processes and turn them into something we can just do reliably, automated. And I'm a trainer. So I'll go in and work with companies and teach them PowerShell or teach them DevOps. So those are my worky bits. And then in the community, I'm really lucky because I'm involved in the PowerShell community and I'm involved in the data community. So I'm an organizer for the PowerShell Conference Europe. I've spoken at the PowerShell Conference in Asia and in what they call PS Saturdays, a bit like SQL Saturdays. I've spoken at user groups, helped to organize PS Days. And in the data community, I speak all over. I go all over, mainly Europe, but all over the world, and go and talk and have loads of fun meeting people. In the open source world, I'm one of the early contributors to DBA tools. I'm a DBA tools evangelist. I go out and talk and train about it all of the time. And Christy Lemaire and I have written a book called DBA Tools in a Month of Lunches, which is available as a MEEP right now from Manning. MEEP means they reckon we're going to finish it when we've done enough for them to start giving you chapters. And I wrote DBA checks, which enables you to validate your environment using PowerShell. And all of that's relevant to what we're going to learn through the day. So, most important, number one fact for you to know about me is that I am not a Unix guy. I am not a Linux guy. I'm a command shell guy, for sure. I love working on the command line. But I do not know all of the magical Unixy things. In fact, that joke's funny because the number of times I forget to sudo things that I need to sudo. Like, it's cool. But here's the thing. In this new cross-platform world that we live in, you're able to do your job by just picking up a machine Doesn't matter what operating system it is, and getting on and doing it. And I know this for a fact, because this machine is my work machine. It's got Windows 10 on it. It's what we're looking at right now. This machine is my old machine. Dell had this issue with some software, which meant that you had continual blue screen of deaths. Kind of makes life a bit difficult to do any work when every 5 minutes it's going off. So I spent a weekend trying to troubleshoot this problem, trying to work out what was going on, diving through all of that blue screen of death goodness. And I got to the end, I'm like, I can't fix this. And on Monday, I have to go to work. And it's now mid-afternoon on a Sunday. What can I do? So I took this old machine, and I thought, you know what? I'll just install Ubuntu on it. So it's running Ubuntu. I put PowerShell core on it. I put Visual Studio Code on it. I put Azure Data Studio on it. And then I worked using that for the next 3 weeks. I did conferences. I did pre-cons. I worked with clients. I was able to do my job completely just using Ubuntu, never having used Ubuntu before, with those 3 tools in the browser, because that's the world that we live in today. So don't be scared of going and trying it out. If you've got an old laptop, just go and stick Ubuntu on it and just see what happens. It's kind of cool. It's an operating system, you click around. Some things are different, some things are the same. But the tooling that you can use is identical. You want to run Docker? Docker's the same. You want to connect to an instance, then we can use Azure Data Studio. If we want to run PowerShell, we want to do any coding, we can use Visual Studio Code. So let's talk about PowerShell. I'm not going all the way back to 2002 when Jeffrey Snover wrote the Monad Manifesto. But by 2006, we had PowerShell 1.0 coming in with snap-ins, mainly driven by the fact that the Exchange team wanted to be able to use command line. In October 2009, PowerShell version 2.0 was released, and everybody was able to do much more. PowerShell version 3 in 2012 really changed how people thought about what they could do in the command shell. It brought us the ISE, brought us the blue screen that we're much more used to working with. It very quickly was an improvement to PowerShell version 4. And in February 2016, we went to PowerShell version 5, WMF 5.0, all of this new goodness. Less than a year later, we went to Windows PowerShell 5.1. We had a name change and a new version. And the reason that we had a name change was that so that people understood that this Windows PowerShell 5.1 was for Windows machines on a Windows operating system. We needed to identify which operating system we're on. Now, Windows PowerShell 5.1 finished. I do not mean gone, not to be used. I mean completed. Think of it as job done. There will be no major changes to Windows PowerShell 5.1 unless there is a massive security bug. It's the only thing where you're going to see some improvements. And Windows PowerShell 5.1 includes the ISE, the coding scripting environment. I haven't used the ISE in anger in probably 3 years now, since Visual Studio Code came out and became available. And I thoroughly recommend that whether you're using Windows or whether you're using Linux, that you use Visual Studio Code as your scripting environment for PowerShell and for many other languages that you want to use. So that was all Windows. And we knew that there was something coming through called PowerShell Core. So notice there's a name change. PowerShell Core 6.0 came out in January 2018. 6.1 came out in September 2018. 6.2 came out in March 2019. This is all done open source on GitHub. So you can interact with the team and push them in the way that you would like the product to go. How cool is that? PowerShell Core 6 works cross-platform. You have the same experience on Windows as you do on Linux, as you do on Mac OS. Same thing is going to happen when you type in the commands. Yeah, in general. Okay. But the thing was that the next thing that happened was we want to improve. We want to go to PowerShell 7. And it's actually called PowerShell 7. I keep the core there so you understand that PowerShell 7 is based on .NET Core 3.0. PowerShell Core 6 is on .NET Core. So as the .NET Core team have improved that product, the PowerShell team are then taking those improvements and enabling you to use them within PowerShell Core, which is 6, or now PowerShell 7, which is coming out and will be released soon. You can get the preview versions. You can go and see what's happening. I won't show PowerShell 7 today, but there's some good improvements and some good speed improvements, some interesting changes in the way they're going to use language in the future. .NET Core enables us to interact with the native APIs of the operating system that we're connected to. So within a Windows machine, we can connect to those Windows APIs and do all the things that we expect. And now it's the same within Unix and within Mac. And gradually, as we move forward, that experience is going to get closer and closer and closer together until they reach parity. That statement means that right now there's not quite parity between what you can do on your different operating systems. The language is the same. The way you interact with it is the same. But some of the features that you have available to you are going to be different. Oh, yeah. So we had a name change. So we've had some name changes. We've gone from PowerShell to Windows PowerShell to PowerShell Core, now back to PowerShell again, just to keep us, awake, make sure we know what we're doing. And the executable, the actual application that's running PowerShell, for Windows PowerShell 5.1 and all of those PowerShells before, was called PowerShell.exe. Now we've got, we don't know how we can say it. There literally, there was a great long GitHub discussion about how we pronounce this. So however you want to pronounce it, that's correct. It's basically as I think the answer is. And we're not using posh.exe because of this conflicts with other executables with that name. We had to find a name that was unique, and that meant that it was something that we couldn't spell. And it's like trying to find a short domain name. You're just not going to do it. They've all been taken. So why are we going to use PowerShell? Well, I'm going to use PowerShell because I use PowerShell all the time. Yeah. Why should you use PowerShell? Hang on. There's an important reason for this. So you can see, I said it wasn't easy for us to mistake. And if you turn around to the back of the room, you'll see why. Hi, Pinal. They all came in wanting to know something clever about T-SQL, and I'm like, no, we're going to learn PowerShell. You'll do it at 11:15. So, where are we? Ah, yes. Whatever that is. So, PowerShell is a shell language and a scripting language. So, kind of got two things that you can do here. We can do things at the command line, make sure that they're really quick. And we can write scripts that enable us to store and have repeatable functionality. As we've said, from now on, whenever I say PowerShell, I mean PowerShell Core. It's cross-platform. It's multi-operating system. It's multi-cloud. Enables you to work with containers. Everything that you interact with in your daily work life these days, you are going to be able to interact with PowerShell, unless you're connecting to DB2 or you've got some of those really old Unix systems which are still around. But SQL Server 2000, yeah, we can still connect to that with PowerShell from PowerShell Core. on Linux. Use DBA tools. I've done it. It works. Click. Thank you. And that means that it's worth using on your environment, because you have all of those things. You need to be able to interact with them. If you're a DBA, you're not just interacting with SQL Server. Now we're interacting with Azure SQL Database and managed instances, storage accounts, network security groups and resource groups and Hyper-V and VMware and all of those things. And we can use PowerShell to connect to any and all of those. Oh, come on. I don't have many Unix people in here, which is fine. Why can't we use some other languages? Most important thing about this next couple of minutes. I'm not saying that these other languages are not awesome. Absolutely. They do the job as they are expected to do. But what I would say is the other languages, your Pythons and your Rubys and your all of these other things that you might want to script with, generally, most of them were not designed to be installed on Windows. They can be, but they were developed for a Unix operating system. And this means that when you try and install them, sometimes you have to jump through some funny hoops. Sometimes weird things happen, and you have to try and muck about with them to make them work as you expect them to do on Windows. And then that means you don't trust really what's going on with them. And you can have some issues because these languages have not been written to be cross-platform. They've been written to do their thing. You can have issues when you try and run the same code on a Unix machine and then on a Windows machine and get different results. I'm sure that the clever people who love to work with this thing and work out what these bugs are and have workarounds and things can make these things less of a problem for you. Your mileage might vary, but I will say if you use PowerShell, that you will find that that experience is much better cross-platform. And the world we're living in now is cross-platform. So what's PowerShell good for? PowerShell is good for interacting with web services. The invoke REST method and invoke web request commandlets have been massively updated within PowerShell core, and they enable you to interact with any APIs or websites really quickly. There's lots of speed improvements. There's lots of capability to authenticate. They're brilliant. Data conversion and manipulation. This is not designed for doing ETL. My good friend Andre Kaman has done some sessions on using PowerShell as an ETL tool because he can. But as with all things, choose the best tool for the job. And just because you can doesn't mean that you should. But in this scenario where we're talking about data conversion and manipulation, we're not talking about great big data sets held in relational databases or in non-relational databases. We're talking about the query results that you get back from an API, a lump of JSON, or the things that you get back when you go and query Hyper-V for how many VMs you've got. Being able to manipulate and convert that data and change it into XML if you want to, or JSON, or text, or CSV, or Excel, or any of those things. These are all things that PowerShell is good for. CI/CD, build, deployment scripts, all of the DevOps goodness. PowerShell is absolutely brilliant. As we were talking about just now, we can connect to all of these different types of infrastructure, all of these different systems. Then we can just run our build scripts using PowerShell. Pester. Pester enables us to validate the code that we write, to do unit tests to make sure it does exactly what we want, but also it enables us to validate our infrastructure. And what I always say is anything that you can get with PowerShell, you can test with Pester. So if we can interact with all of these different systems cross-platform and get information about them, now we can write test tests to validate that they are as we expect them to be. Some things it's not so good at. Deep system integration. Because you've got to do a lot of coding to make sure that when you're looking at a Windows machine, you're doing this thing. When you're working on a Unix machine, you're doing it here. When you're going on Mac, you're going to do it here. So those, maybe not quite so good for them. Displaying interfaces, GUIs. The GUI experience on each of those 3 cross-platform operating systems is slightly different. PowerShell's a scripting language and a shell. So whilst you can build some GUI infrastructure there, perhaps it's not the best thing to do with PowerShell. Maybe you want to try a different tooling and possibly make that connect to some PowerShell behind the scenes. And again, colorized output from binaries. Same thing. It's a scripting language. Let's use it as a scripting language. So actually there's quite a lot of grey beards in this room, but for the young people, this is a floppy disk. It's called that because it's well, it's not floppy. Actually, this is version 2. I couldn't find a picture of a real floppy disk. Can you believe that? We can install PowerShell. So when we were on Windows machines, PowerShell came embedded with the operating system. And when we wanted to upgrade, we could go and download and install Windows Management Framework, whichever version we needed, and we can run through and do those updates. Now, being able to install PowerShell is so small that it fits in a tweet. So Steve Lee is the program manager for PowerShell, works up in Redmond, and you can install PowerShell core on a Windows machine with 1 line of code, IEX, and blah, 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 blah. And also, if you're running on Unix and you want to install with bash, then you can just do a wget and then pipe the results of that to sudo bash. Really is that simple. All right. You can do it like that. More seriously, if you're on a Mac, you're going to use brew, to do an install of PowerShell, just like that. And even though it says PowerShell, that's going to be installing PowerShell core, push. On Linux, depending on your version, you're going to do a sudo apt-get, or a sudo yum, or a sudo dnf. Install -y PowerShell. Simple. These are not difficult problems. If you want to update, guess what? Sudo apt-get update PowerShell. If you want to do this on Windows with the same sort of experience, make use of Chocolatey. Who here has not heard about Chocolatey? Does not know what Chocolatey is? A few of you. OK. So Chocolatey is a package manager for enabling you to install systems in the same way as we've got our apt-get or our yum repositories for our packages for things that we wish to install. Chocolatey enables us to do the same thing at the command line. So we had a conversation about this machine and when it was blue screen of death, and we had to reinstall. And then once you've reinstalled your Windows laptop, you then have to go and download all of these binaries and then do your installations and all of that thing. Or I go to my gist, I copy my Chocolatey install script, and I run it in PowerShell, and I leave it to do its stuff. I come back, and then everything I need is installed on my machine. So Chocolatey is a brilliant way of doing that. So you could just run choco install PowerShell core, because Chocolatey would let you install a Windows PowerShell, and a -y, and then it's going to go off and do that thing. Any questions about installation of PowerShell core? It's pretty simple, isn't it? Here's a nice short link, aka .ms pscore6. It's going to give you all of the goodness that you need to be able to find out how to install and interact with PowerShell core. So we need to talk about some work. What we're going to do with our PowerShell. Who uses Windows PowerShell? Carry on. Like, carry on. All of those skills that you've learned, all of those snippets that you have, all of those scripts that you have, they're pretty much going to run exactly the same in PowerShell core on Linux than they do in Windows PowerShell on Windows. Some things might not be quite the same. If you're on an Ubuntu machine and you run get-services, then don't, because there aren't any. Yeah? Just like I say with DBA tools will do everything. It'll connect to all of these versions, but it's not going to show you the availability groups on a SQL Server 2000 box, because there aren't any. Same principle applies with your PowerShell. To be able to do everything that you need to do in PowerShell, you need 4 things. And I'm going to explain these 4 things and repeat them a few times. Not because I want you to learn them as, if I am learning how to use PowerShell, these are the 4 things that I need. Actually, because if you are using PowerShell, these are the 4 things that you should make sure you do every single day. I promise you, I've been working with PowerShell for a decade now, and I still use all 4 of these every single day. I need to find out how to use a thing. DBA Tools has 564 commands. I cannot remember all of them. So I need to use get-commands and a search term, the stars make it a wildcard, for whatever it is that I want to find. As well as DBA Tools, you have all of the other modules that you're going to want to use. They're all going to have commands. This is how we go and find them out. In general, PowerShell works pretty much, PowerShell naming convention is pretty much what you expect it to be. If you want to get some databases, then the command is get-dba database. Okay. If you want to get your VMs from Hyper-V, the command is get-vm. So when you don't quite know what it is, like sometimes some of these Azure ones where the command name is like this long, just do a search. Find out what it is, which command is it I want to do for the thing that you think that you want to do. And a bit like your Google searching, you'll get better at that over time, being able to filter that down. Once you've found a command that looks like it's going to do exactly what you want it to do, then we do get-help name of command. That is then going to tell you exactly what is going to be available to you for that command. If you do it with a -full or a -detailed, you're going to get all of the help, which is going to include all the examples. It's going to have all the syntax. It's going to tell you the data types for all your parameters and what they're used for. It's like your man page, if we were turning that into a Unix thing. It's going to give you exactly the same sort of information. PowerShell has the built-in help to enable you to help yourself. So we've done get command. We've found the command that we want to use. Now we use get help to understand how it is that we use it. We probably do a -examples. Look at those examples and go and try them out. Now we need to understand what it is that we're doing. In general, I will use a $name of a variable. When you see a $sign in PowerShell, it means this is a variable that we are storing within our process. I make that equal to, with the equal sign, the command that you're running. So, $databases equals get-dba database -SQL instance localhost. You're not going to get an output. You're just going to have those results stored within that variable. Once you've got that, you take the variable and you pipe to get-member. If you're doing it at the command line, you're just going to use gm. That's an alias. Aliases are great. I used to mess with my Unix guys' heads because I would jump on a box and I'd do ls. And they'd be like, what? I'd cat a file. They'd be like, woo, that's a Windows machine. I'm yeah, sure. It's PowerShell. We've got these aliases. They've taken away some of my fun now because we need to be able to run those things on Unix. So the cat needs to go to the cat command and not to get-content, which is what it did go to. But we explore the variable that we've got, and we pipe that through to get member, it's going to give us all of the events, all of the properties, all of the methods that are available to us on the object that comes back from PowerShell. Very important word that I said there. Object. This is the biggest, most difficult challenge for people who are used to working with Unix to comprehend about what comes back from a PowerShell command. Because if we write a command in bash, what we get back is a string of text. And then we can awk and grep and sed and other things with it to do stuff that I don't really quite understand. But it's text manipulation. All of that regex and stuff we need to do. When we're working with PowerShell and we run a command, what we get back is an object. Now, sure, if we're doing a get-content on a file, what we get back is a string, some text. Even that is an object. It has properties. We don't need to, for example, count how many characters we have in this string of text to understand how big it is. Because what we have is an object which has a property of length, which tells us how big it is. Same with a file. If we're getting back a file, we're not just getting back the name of the file and maybe a string representation of the ACL on that file. What we're getting back is a file object with all of the capability to do many things and having many properties available to us to work with. Those property values are where you're going to find your strings. And as data people, what you're probably going to do is you're going to find your variable and whatever, and you're going to pipe it to select. Once you've done your get member and you found your properties, you're probably going to do select name of properties. So in effect, what you're doing is doing select name from sys.tables. Or here you might do get-dba table, pipe, select name. You start to get your head around the way these things are working, then you're going to be able to take yourself much further. But what you're getting back then when you're selecting something from a property is actually your text. That is going to be a string. So we need to know where things live when we're working in PowerShell core. So if I'm on a Windows machine, I'll always say, no, start that again, because what we need to do is we need to point out. I think the battery might be going in my machine, in my pointer. If you look at the $env, dollar is a variable. Because it's env, it's an environmental variable. And then we have a colon, and we're saying we're picking the environmental variable PS module path. And the PS module path is the place where PowerShell will go to look to see which modules it has available for it to install by default in your session, should you require them. Doesn't load them all in at first, just goes and sees where they are, reads the module.pds1 file, sees what commands it has available, and goes, right, cool. So when we do our get-command, that's the information that it's using to give you back what commands you've got. Then we go start and look at what's going on. It's going to load the module in, grab the help, and give it to you for your get help. Then when you run it and put the results from the command into a variable, the module's going to be loaded, and you're going to start running with it. Those modules are going to live in these places. In a Windows machine, you're going to see there's going to be a lot depending on what you've got installed. Your default ones are going to be C, program files, PowerShell, modules, because we're talking about core here. Forget Windows PowerShell. And then you'll find that there'll be a user one, users, documents, PowerShell, modules. Pretty much the same thing going on there, right? So we've pretty much got our admin user account profile, PowerShell modules, and then we've got some other paths that we've got. But normally I'll do a split on a semicolon because that's how it's put into our environmental variables in Windows. Here's something you're going to want to learn how to do and understand when you're using PowerShell core and you're wanting to make yourself available for any machine. Is that actually, probably what we want to do here is use the system.io.path.net core method path separator to be able to make sure that this will work on any of the machines. Our profile in PowerShell is the code that runs when we start up our session, enabling us to have all of the things that we want for that particular session. Maybe we want a different sort of prompt. Maybe you want to load in some default variables, like the path to your instance database, path to your pester files, those sort of things. And these, like they do within Windows Machine, live in various different places. So all users and all hosts will use the first profile, and then it'll go all the way down until you get to the current user and the current host, and they will use the last profile that you've got there. So all the different places that you can put your profile. Gonna work? Woohoo. Once you get into the hang of using PowerShell and you love it so much that you think, I don't want to use bash unless I particularly really need to go through and do it, you might want to set PowerShell as your default shell within your Linux environment. So what you do first is you identify which shells that you have. So you do a cat-etc-shell. And that's going to say, here you go. Here are all the valid shells that we have available to us on our Unix machine. And you'll notice that we've got POSH PowerShell there twice. One opt Microsoft PowerShell 6. And one, the symlink to users bin pwsh. The shell that we're going to use is going to be the symlink, because that's going to stay as it will be for all future releases. And then it doesn't matter what we've got down behind. Think of it like a DNS name, like a C name. It's a pointer to tell us where our executable is going to be. So we know which shell we're going to use. We're going to use the default shell /user/bin/pwsh, which is going to then point us to the correct executable. And then you do chsh, this is my shell, /. Give it the user that's going to be the default shell that you want to use. So for Rob admin, the account that's logged in, I would like this to be my default shell. And then you'll need to put your password in. Now, when you open up bash, everything will be fine. Linux is case sensitive by default. Windows is not case sensitive by default. We are used to, for so many years, creating ourselves files and folders with capital letters or not capital letters and accessing them with capital letters or with not capital letters, and it doesn't matter. This will bite you on the behind if you do it in Unix. Okay? I've done it. Oh, yeah. I've created a file as databases with a little d, and then gone to try and find it with databases with a capital D, and everything falls over, and you get red text everywhere. I've done it. You'll do it. But environmental variables on Linux, they're case sensitive, just like the file system. So all of those environmental variables, they all use all caps. Of course, with all good rules, there's an exception. So you know that you've got an environmental variable and you've got it in all capital letters, apart from PS module path. Yeah, PS module path is using, that's camel case, isn't it? There. For reasons, we'll leave it there. There are good reasons why it needs to be like that, and that's the one we've got to just make sure. Because if you try to use all caps for that one, it's not going to work. its own special snowflake. Import module. Okay. So we talked about how when we load our modules into our PS module path, they're automatically available for our particular session. How when the PowerShell session starts, it goes and looks through those paths for the modules available to it, grabs the PSD1, has a look through there, finds all the commands that are available to you, makes that ready for you. But sometimes you're going to want to import modules that you've got stored in different places, maybe on a network share, maybe within your source control when you're trying to do some development work. On Linux, import module is going to do some funky things. So you can see that I am connected to an Ubuntu. This is WSL, so this is Windows Subsystem on Linux, which is a great way of learning how Linux works without actually having Linux installed. And if we do a get module list available, it's going to show us all of these modules are available to us. And if we try to do an import module, PS readline, you notice it's got capitals, nothing happens. No error message, nothing happens. Because there is no module called PS readline all in smalls. Because PS readline is in camel case. So if we go and look at the module, select our module base, we can see where our module is living. You can do this for any module. So if we go and try and import the file precisely, the PSD1 file that's our module that we would have used created when we were doing our development work. And we know that the operating system is case sensitive, so we make sure that we type everything in with the correct casing. And we do PS readline all the way through, and then we go, oh no, it's okay, we'll just do PS readline.psd1. Nope. Then you get an error. No valid module, because that file doesn't exist. But when we put in the correct casing for that file, in it comes. And then our PS readline module is imported into our session. If we're working on cross-platform and we have these differences in path separators, for example, we need to be able to identify which operating system we're running on. PowerShell core has these default environmental variables. Not environmental variables, it has these default variables. There's no $env there. You've got is Linux, is Mac OS, is Windows, is core CLR. Your ordinary everyday variables that you use and the ones that you create are not case sensitive. So if you type is Linux all in small letters, you're going to get the results of that variable. Some tricks that we might want as a Unix person to be able to work with files that we're getting from text. If you use convert from string data, this works on Windows as well as on Unix. What that's going to do is it's going to grab you the contents of the file, and then convert from string data is going to turn that into a hash table, an object that you can then work with within your PowerShell. It's going to look like something like that. So if we look at the content of the file at the top, you can see that it's key value pairs. Yeah? We've got name equals Ubuntu. We've got version equals 1804, like this. We convert it from string data. We now have a name and a value hash table, an object that we can then work with, and we can get those properties out and code with them as we wish. In general, when we're using file system, in Windows, we generally don't really care. In Unix, we really do care. Use UTF-8. ASCII, if you get really weird things coming out, but UTF-8. It's really easy to do in Visual Studio Code. You look down at the bottom, it's going to tell you what your encoding is going to be. You can do an F1, you click on the encoding, and you can reopen with a new encoding, or you can save with an encoding. Choose the one that you want. You can do it straight from the command line with a get content to a variable, and then a send content, change the encoding. Line endings. Again, for Windows, we've not been bothered about this for a long time. Now, Windows apps will, in general, just accept a /n. Linux, no. Linux is going to require that it is just a /n. And /r/n is what we will generally create within Windows. So to help you, in Visual Studio Code, you go and install an extension called render CRLF, carriage return line feed, line endings. We've still got that good old printer, that typewriter stuff coming through. I love it. And you'll be able to see, not very well, because it doesn't need to stand out well, but you can see that we've got a line feed at the top. It's going to come out just as an arrow. And we've got a carriage return, which is going to come out like a carriage return. So, the slash in our file paths. Yeah, Unix goes one way, Windows goes the other way, URLs go which way. So you all know how it is that you identify which slash it is. I've got a really simple solution that you're going to remember now. Okay, so Guns N' Roses. Slash is the guitarist, yeah? Great big top hat, masses of hair, normally a cigarette, and a guitar. So, // // Yep, you're going to remember that one. Now, when you need to talk to people, you're going to tell them that that's what it is. Yeah, I'll give you a minute just to do that. Yeah. So when we're talking about using slash, not the guitarist, but the line separator, path separator, Windows PowerShell doesn't care. You can use whichever slash you want in either Unix or Windows. So if you look at that, you can see that I have asked it for the path, and the path, the slash is // /temp / beard. But if I do a get child item /temp / beard, it gives me the files. Doesn't care. And oh yeah, same thing works on Windows. So if you're in Windows and you're using PowerShell core, you can just put your slashes any which way around, and it's going to work with your paths. So cool. Now, when we're doing our coding, we're going to write some PowerShell. We can make use of some of these things that we've learned. So we've got a base path. This is a switch operator at the top. If you don't know how to write a switch operator, in Visual Studio Code, you just start typing switch, and you'll get a snippet that will come up that you can just tab, and it will give you the syntax that you need to be able to write a switch statement. I'm going to say if it is Windows, then I want you to use the $env temp environmental variable to my local user temp path. And if it's on Linux, then I'd like you to use /temp. What we've done in the past with Windows PowerShell is we've concatenated our strings together to make our paths. It's much better, now we're working cross-platform, to use join path. Join path is going to take our base path, and then it's going to have a child path of sock factory. This is a joke with myself and Gianluca Sartori. He's a wonderful Italian man who works for a Formula One team based in Italy. Yet that Formula One team based in Italy. And when you ask him where he works, he says, I work at a sock factory. So we've got a folder called users and permissions with inside our sock factory. When we want to create that dynamically, we're going to use that with our join path. And that means that whether we're working on Unix or whether we're working on Windows, if we use our join path, it's going to create the path in the temp file that we want, depending on our operating system. Which editor do we use? I think you all know the answer I'm going to say. Visual Studio Code, of course. It's cross-platform. It's going to work the same all the way. It means that non-Unix guys can work on an Ubuntu for as long as they want to, because it's always going to be the same. Here is our code to be able to install Visual Studio Code depending on our operating system. It looks pretty much like what we had for PowerShell because it's pretty much like what we had for PowerShell. Script Analyzer enables us to see what is wrong with our PowerShell scripts that we write. It's the thing that gives you your squiggly lines in Visual Studio Code when you make a mistake. And we're going to use that to make sure that we can do everything we need within all of our operating systems. You've got a whole different set of rules to enable you to validate these code that you're writing. So maybe avoid global aliases. Don't write code that sets a variable to be, sets an alias to be global, because you might mess something else up. Don't set an alias to be cat, because on Unix it's going to do something different to what it does on Windows. So we can check our scripts at the command line. We can run invoke script analyzer, give it a path to a script, and it's going to tell you that, oh, hang on a minute, you're using WMI. WMI is deprecated, don't use it, use sim. It's going to say avoid using hard-coded computer names, because you want to write scripts that are capable of taking parameters that you can use with any computer. And it's going to say avoid using any aliases at all, especially commander aliases, because otherwise you'll have to go and search Google for %. You ever tried searching Google for % to find out what it means? These days, actually, if you search PowerShell and %, you do get an answer that tells you what a % means in PowerShell. A decade ago, you did not get that. So I searched for PowerShell %, PowerShell %, PowerShell double quote %, PowerShell single quote %, PowerShell %. It took me like 2 months to work out, or to find something that told me what a % sign means. When we're using Visual Studio Code to create and develop our PowerShell, we can open up a workspace. Within that workspace, we can set a lot of settings that are available just for that set of folders that we're using at that moment in time. And we're going to use Script Analyzer inside VS Code to make sure that the code that we write is available cross-platform. So you can see this comes in by default. It's there, just available to us. We get some nice squiggly goodness. We're going to see what's going on. % is an alias for each object. Oh, I wish I'd had Visual Studio Code a decade ago. And the squiggly line tells me where I'm using it and how I can fix it. And it's also got the capability to click the light bulb and fix it as well. But now we've gone a step further. The PowerShell team have written script analyzer rules that can allow you to check your scripts for compatibility between versions and between operating systems. So if you go and look for script analyzer compatibility checking, you're going to find a blog post by Rob Holt, who's a member of the PowerShell team, who did most of this. And he's got 3 new script analyzer rules: compatible syntax, compatible commands, and compatible types. And that means that you can do things like this. We fixed our script using Visual Studio Code, so we've got no squiggles. That's all good. Now, we're going to create a settings file. It's going to look like this. All of this stuff is in my demos, my slides, which you can find on GitHub. Look for SQL DBA with a beard. Go to my presentations folder. You know what year you were in. You know which event that you're at. You know which session you've come to. Now you can find all of this. We're going to create a JSON file that's going to hold our settings. And it's going to say, you see, Windows 8, x64, blah, 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 PowerShell core on Windows. And then the second one of our target profiles is Ubuntu, 64, PowerShell core on Ubuntu. So that's going to enable us to check that the commands in the code that we're writing are going to work with those versions. And, sorry, with those operating systems. And then our compatible syntax is going to check that we can write code for version 6.1 and 6.2. We only want this to work on core. We just want to make sure it works across platform. We can run invoke script analyzer and then use the settings parameter, pass in those settings. It's going to tell us, oh, baby, this stuff isn't going to work. These are the things that you need to change. Computer name is no longer valid. Nope, it's not that one at all. Use the one below. The parameter class is not available for the getSim commandlets in PowerShell core. Work on Windows PowerShell, won't work on PowerShell core. So it's going to come up and tell us, give us a warning. If we save those settings that we've created as a file, preferably within the workspace that we've created in Visual Studio Code, we can make that automatic within Visual Studio Code. I would do this at a workspace level for that piece of code that you're writing, project that you're writing, if you like. And you press F, no, you don't press F1. You click on the cog, and you get the settings. And then in the settings, you search for script analyzer. I will always get it wrong, because I use an S and not a Z, but I can find it eventually. And then you look for the script analysis settings path, and you put in the hard-coded value to that settings file that you've created. Like that. But you do it on the workspace. If you wanted to change it for everything, you could do it on the user. If you wanted it for the folder, you could put it in the folder. But do it for the workspace. Create a workspace and save it for yourselves. And then automatically within Visual Studio Code, you're getting all of that goodness, got the squiggly goodness for cross-platform scripting. We've got 20 minutes, just under. Please do your session evaluations. Don't forget to say why. He was really good because his beard is awesome. Or he was really rubbish because I didn't understand his accent and he spoke too quickly. It's fine. If you just say he was really bad, a 1 or a 5, whichever way round it goes, and don't put anything in, doesn't help me be better for next time. We get all that. Right. Everybody cross your fingers. OK, here we go. Unplug from that one. And we're going to plug into this one. Yay! 7 o'clock this morning, that didn't work. So, I am not going to sit on this. I am going to make sure my mouse is connected. There we go. So if we look at code.visualstudio.com, you can see you've got capability to download the package and install it on any operating system. If we go to look at how we install PowerShell core, you've got the full set of instructions on the documentation. Just copy and paste those, and then you can do your installation. Whoa, baby. Give me some of this. So, Control and plus and 0, it's just Visual Studio Code, so we can make sure that we can set the color theme to be something more suitable. If you want to make it look like you're running ISE, you can even kind of make it look like that too here. But we'll go with the default one. And you can see that here I'm just running in bash, so I can do some ls. Yeah, it's good. If I just do pwsh, and tell me I'm in PowerShell core 6.2.3, and now you see it's loaded my profile. So I've got a little bit of colors going on down below there.
Question.
Yes, sir.
If you have Windows from Linux,
Yep.
can your Visual Studio Code run bash?
Yes.
Yeah.
Yes. If I was brave enough to swap that back to that one, I'd show you, but I'm not. So now we can make sure we're in the right location. We can check our version table. That's always going to show us. Let's put this over here. See if that looks a little bit better. Here we go. So we do that. That's going to show us our version. It tells us that we're running an edition called core. So we know we're on PowerShell core. And where OS is Linux. So we need to find some commands. We're on Unix, so we're going to go and find some commands to do with process. Wow, there we go. You can see how the command that we want to run is probably named the way that we expect it to be named. We can read those command names and understand what they're going to do. So I'm going to want to get my processes. How can I get my processes? Just use get help. It's going to get all of my information. If you want even more detail, then if we do the details, you can see that we're going to get all the different versions of the syntax that we can use. And you'll learn to read what all of those symbols mean and how you can use it. We've got our parameters here, so you can see it doesn't have an awful lot of help with our get process as to how to use those. You can use the online tag, so then you could open maybe the web page up in a separate monitor so that you could understand how to use something and still have your code open on one screen. You can use aliases. Do not, under any circumstances, use aliases in code that you share online, otherwise you will face the wrath of the beard. Okay? Remember the story about searching for %? I'm still angry about that. Many years later, that is why you do not use aliases. One of the reasons. But we can use aliases. And yeah, I know, I'm literally doing the thing that I'm telling you not to do by sharing this code on my GitHub, but there's a point. We can use GPS at the command line, so we can work really quickly at the command line. And get process is going to give us all of the processes that are running. So maybe we want to find the process called Whoopsie. I didn't know there was a process called Whoopsie. It was hilarious. Now, we do an up arrow. We can now, oh no, it's not that machine, it's this machine. There we go. We can set this to a variable. We'll call the variable Jeremy. No, we won't. Jeremy. There we go. And Jeremy is going to equal that. You're going to get no output. But what we've got here is our, gee whiz, is our variable, Jeremy, is going to still be that object representing that process. It doesn't refresh. It's a static version, but it is still that object. And then if we pipe that to GM, that's what you're going to do at the command line. It's going to show you that you have all of these other properties that you didn't see first time, because we only saw the default view. We've actually got all of these other properties that we've got available to look at us for this process object. And we've also got some methods. So we could close this project. We probably want to dispose this process. That'd be a better way of doing it. Let's just kill it. Yeah, bang. Let's get rid of this. And you can see what type it is. It is a type of system.diagnostics.process. That is the type of the object, which will enable you to go and find within Google how we can make use of this in PowerShell, if that's what you want to do. This is how you are going to work. So there's this, I was on the SQL train coming back up, and Kellen Van Gorman said, so how do I do sed and awk and grep? And I'm like, okay, tell me what they do, because I don't really, I know I've seen them and I've actually run scripts doing it, but I don't really know what they do. And she started to sort of explain some of these things that these different Unix do. And then I realized that actually that's really important to people who are just used to working in Unix. So if we kind of look at grep, grep is getting us something from a file that matches, something from a string that matches some sort of regular expression. And once you explain it like that, I'm like, oh, okay, right. So let's just get ourselves the content of a file. Here we go. Some of you will know what that is. There we go. And perhaps now we just want to grep that for nothing. The word nothing. So we're going to grep where PS item, this thing, matches nothing. Code that you can kind of understand and read. And if we do an F8, you can see it's Nothing Else Matters by Metallica. It's just the lyrics. Now, Unix people like to get stuff shorter and shorter and shorter. And in fact, there are many PowerShell people that like to do stuff just on one line. I hate it because it makes it really difficult for you guys to understand what is going on. So we always start with the top one. And we always share the top one. But you can do a cat of the data.txt file, and you can pipe that to where matches nothing. In fact, you can even take it smaller, and you could take it down to using the question mark. So you can grep your object. Now, I've done it for the content of a file, but it could just be any string object that you get back. Don't forget, your PowerShell's not returning strings. It's returning an object. So if you try and do a grep on a database object, you're going to find a lot of red text. It's not going to work. So we talked about sed. So sed, as I understand it, enables you to replace things on a regex from a string output that you get. And I'm getting nods from my Unix friend here, so obviously I'm saying something correct. Right? So I'm like, OK, now that begins to make sense. So now I can do a get content on my file to get me a string object to be easy. And for each object, I'm now going to take this object and replace matters with is important. So we do that, so you can see nothing else is important. I don't like these new lyrics, but we'll run with it. Perhaps James, that's what he wants. Now, the other thing that sed does is it might put it back into a file. We might grab a file and then try and set. So what we can do is we can do a get content on our file, get as our string object. We'll do our replacement, and then we can actually also do our grep as well, just by piping the object along. And then maybe we want to set it into a file. And if we then go and have a look in our file, where's the files? There we go. We've got data1, and you can see we've done a grep and a sed and stuck the results into a file. And that's how you would go about doing that. But it's objects, so there are other ways of achieving similar things. And we've just then done some piping. So if we look at our PowerShell, we've got a few versions of PowerShell. Open PowerShell to the side, Rob. OK, thank you. Right, let's get rid of that one. Let's get rid of that one a minute. Let's follow my instructions that I've given myself. So we're going to go to the side, and we're going to open PowerShell. Look at this, Visual Studio Code. I could actually run, if I kill that off, I could run bash, and then I could split it out, and I can have bash, and I could have posh on that side. Do it on Windows, you can do command line, you can do WSL, you can have everything all lined up together and do the same thing. Now I've distracted myself, and there we go. Let's do that. So now we've got posh on both sides, two different versions. So it means that in this side, when we do a get process, you can see we've got 3. Excellent. We've still got that one as well. So we go back to our first one. We've got an ID of 6462. Let me guess. This one's probably going to be 2945. This is where I either kill my... Oh, don't do that. 2945. OK. 2945. Is that right? Nope. We need another 4 in there. There we go. So I do my get process ID over in this window. See that I've got my process that I'm running. So now I can take the output of one command and pipe it to another command. So I can now do a stop process. And as you can see over here, we've just killed our process. It's how we can just pass our objects around through our command and pass mode. We know how to explore things. Talked about setting things to variables. We've only got a few minutes, so I'm going to let you follow those instructions. It's the get member stuff that we talked about before. And you can see if you did a database in a get member, you would find that a database was of type SQL Server Management SMO database. And this is how I have done this for all of my life. I go and I search in Google for that. And then maybe I'd put PowerShell for that object and work out how I can use that particular object type when you're doing your exploration. So, you have all of this information here. How we can do our get members. With that, we can find on a table an index property, and we can use the script method to get the T-SQL script out. But let's talk about writing some code. When we start writing our code, we get our IntelliSense. That's coming again from our default path locations. Just loaded this up. So maybe we get our backup history, and we can do minus SQL instance. Control space is then going to open up this, tell us what's going on. We've got our SQL instance. That delay is because we needed to load the module to get the rest of the stuff. SQL instance, because it knows that's what's available within our script. And then we could do a SQL credential and carry on. Sometimes things don't turn up. You press Control space and then they come up. Sometimes they still don't come up. What you do is you go back to this baby, the PowerShell integrated console, which you'll notice I did not run any code in. And if you hit that one, you'll just kill that, and it'll say, hey, would you like to restart? And you go, yes, please, because that's what's giving me all of the squiggly goodness and the capability to have my IntelliSense. So, we don't know how to write a switch statement. Like I said, start writing switch. We've got a snippet. We can press that and it'll come through. That's how easy it is to use Visual Studio Code to write the syntax for your PowerShell. Here's our squiggles. We've got everything using aliases. If we click on one of these, we've got a light bulb, which is going to tell us this is the problem and this is how we can fix it. Enables us to fix our code. But we've also got it in our problems panel here, so it's telling us that where is an alias of where object. And when I click it, it will highlight, show me where that problem is. If we look at our default variables, we are on Core. We are on Linux. We're not on Mac. We're not on Windows. So we can write some logic that means this. If I'm on Core, if I'm Linux, right, I'm a penguin. If I'm Mac, right, I'm a fruit. Windows, right, I have the oddest version naming system. But otherwise, right, hey, wait a minute, we're on Windows PowerShell. So that code's going to work on my Linux machine, on my Mac machine, on my Windows machine running Core, and then on Windows PowerShell. Written some cross-platform code, really simply. So let's take some code very quickly. We're going to run this code. This code runs, cool person. Drew, how do you say it? Good, none of you can do it either. So, it works fine, but will it work on a Windows machine? We're working on Linux here. Will this work on a Windows machine? If we open up our script analyzer file and look at our instructions, what do? We can uncomment lines 5.1. I want my code to be compatible with 5.1 and with 3. When we save that, now if I just poke this file, script analyzer will not come up. Excellent, thank you. Thanks, script analyzer. We restart that. We could run our, excellent, let's clear you. We could run an invoke script analyzer to see what I should have got, and that's why I do this. And it's going to tell me that you're not running PowerShell, Rob. Thank you. And it's going to tell me that a strange thing has happened. What have I done? Oh, I'm in the wrong place. 2019, past summit, push. There we go. Right. Let's run that command. A script analyzer is going to take a moment to run when we have this new compatible syntax thing. But it's going to tell me, yes, my where object is incorrect. But it's also going to tell me, if I scroll myself up a little lot, that we've got some trailing white space, and well, blow me down with a feather. I know why. There we go. So you've got the capability to enable it within a setting. If you don't press that true or false, then you don't get the goodness. Let's try it again. There we go. So now you can see the constructor, the code that I wanted to write, that I'm writing in Unix, is not compatible with my Windows machine. And it's going to tell me which lines have got my problem. So 231 is where my issue is. Blatantly isn't, but it's looking at this one here. This is the way that you can write your code within your Linux machine, but still have it available even for Windows PowerShell 3 if you have code that needs to be working on that. So I will answer all of the questions that you like. I'll do one now, but then the rest will come down here so we can get out for the next speaker. Go for it.
What's your recommendation in terms of running a query against SQL Server? Should we use some folks
So the question is, what do I recommend to use PowerShell to run a query against SQL Server? I recommend you use DBA tools and invoke DBA query. If you have to use invoke SQL command, then make sure you understand all of the issues that you might have with that. So there are things like the timeout setting, which you might set to 0, which will mean that it will time out after 30 seconds. You go, oh, well, I'll change it to 120 seconds, and it will time out after 30 seconds. Okay, so that sort of thing happens. Okay. So my name's been Rob. Hopefully you've learned a little bit about PowerShell, and you can turn and laugh at all the people who are suddenly arriving because they overslept. But have a brilliant rest of past summit. Thank you very much.